Hello everyone. Today we are going to discuss operational amplifier. The previous two classes already I told you operational amplifier. So what are the properties of the operational amplifier, or what are the principle of operational amplifier? So generally in operational amplifier, the basic principle of operational amplifier, it is high gain. Gain means what? As far as voltage gain is concerned. Voltage gain means what? Output by input. As far as voltage gain, it is your output voltage by input voltage. In operational amplifier, the gain is very high. As far as theoretically we will say that is your infinity, but practically it is not infinity. It is very high. So an input impedance is also high. Theoretically also very in order to mega ohm, giga ohm as far as input impedance is concerned, but practically it is very high value. So now today we are going to discuss that is your what? That is your differential amplifier. So already we have covered that is on the op-amp as a summer means op-amp as a summer. Summer is nothing but what? Summer or adder. Summer, or we can say that is your adder. Op-amp as an adder. Adder means what? If you apply the number of input voltages V1, V2, V3, the output voltage V0 is nothing but what? That is your sum of the input voltages. That is your minus of V1 plus V2 plus V3. If I will apply 3 input voltages to the input, the output voltage is nothing but negative of the sum of the input voltage. That is your sum. Output voltage equal to minus of V1 plus V2 plus V3 like this, and with gain. So similarly, by the in case of inverter is, as far as inverter is concerned, already I told you in your previous class, V0 equal to, so minus, that is your R2 by R1, that is a gain, R2 by R1 into V1. If V1 is your input, if V1 is your input voltage, then output voltage is equal to minus of input voltages. That's why we will say that it is op-amp as an inverter. Now today we are going to discuss that is your differential amplifier. So in case of differential amplifier, that is differential amplifier is nothing but that is your what? The if simultaneously if I apply the two voltages here, V1 and V2 here, so that is your, in case of differential amplifier, in generally in previous class I am applying input voltages V1, V2 like this. Similarly here in case of differential amplifier, that simultaneously you will apply two voltages. Suppose this is your V2 here, this is your V1, and this is your lead V2. How will you get V0 equal like this? So in a differential amplifier, already I told you this is your what? That is your VD, difference voltage VD. So same thing, if you apply the Kirchhoff's current law here like this, that is your V2. Suppose this voltage is your V minus, let this is your I1, and let this is your I2. First of all, in case of differential amplifier, one common thing is that we can will we prove that the differential amplifier is nothing but a voltage subtractor also. It is a voltage subtractor. Suppose this voltage is your V2 and this voltage is your V1, and if you apply Kirchhoff's current law at this point, this node here V2 and this is your V minus, if this point is your V minus, so I1 value is how much here? I1 equal to current, I1 equal to V2 minus V minus divided by what? That is your R2. This is your I1. Okay, this is your I1. Similarly, this voltage, V1 voltage. So from this is your V minus is like this, and this is your, again, if I will say this voltage is nothing but V plus. V plus is how much? V plus is nothing but what? That is your, this voltage is nothing but, you can apply voltage division rule. This voltage is nothing but V1 into R1 by R1 plus R2. V1 into R1 by R1 plus R2. If you apply the voltage division rule. In voltage division rule, if you apply a voltage at a particular, across the particular resistor, voltage division means this voltage plus this voltage is nothing but V1. I need this voltage, that is your what? Total voltage V1 into this resistor by sum of the resistor. This is the basic thing how will you find out the voltage division rule. Or otherwise you can find out the current. Current is nothing but what? V1 by R1 plus R2, that is your current, and current I into R1 is nothing but this is your this voltage. So this voltage is nothing but V plus. So this voltage is nothing but V1 into R1 by R1 plus R2. This is your V plus. Let this is your equation 2, and this is your, from this is your from this you can find out that is your what? V minus. From this you can find out V minus. V minus value is how much? That is your, so V minus, and if you apply the Kirchhoff's current law at this node I2, this is your what? This is your V0. So I2 value is how much? I2 equal to, that is your V minus this voltage minus V0 divided by what? That is your R1. That is your what? Now I2. If you apply Kirchhoff's current law at this node, if you apply KCL, Kirchhoff's current law at which node? At V minus, this node. But so incoming current is your I1, outgoing current is your what? That is your I2. So I1 equal to I2. So I1 value is how much? I1 equal to this. I2 value is how much? I2 is nothing but this voltage minus this voltage by R1. So I2 is like this. So if you apply Kirchhoff's current law at this point, I1 equal to I2. So this value is I1 equal to this and I2 equal to this. So I1 equal to, from this relation, I1 equal to I2, I1 value this equal to I2, that is your V minus V0 divided by R1. From this you will find out that is your potential at V minus. So that's why from this that is your V2 minus V minus by R2 equal to, that is your V minus V0 by, that is your R1. Okay, so I1 equal to I2. From this expression you will find out that is your V minus. So V2 by R2, I am separating here V2 by R2 minus V minus by R2 equal to V minus by R1 plus V minus by R1 minus V0 by, that is your what? R1. So V2 by R2 or V0 by V minus V2 by R2 plus V0 by R1 equal to, here minus V minus by R2 going to RHS, that will be plus. So that is your V minus by R1. So V minus by R1 plus V minus by R2. And here that is your V minus taking common, that is your what? That is your 1 by R1 plus 1 by R2. That it becomes what? That is your V minus whole into R1 plus R2 by R1 R2. So that is your, the value is like this. And V minus is how much? I need the potential at this point, because V minus, that is your V minus. So V minus value from this V minus, which equal to, which implies V minus is nothing equal to, that is your what? Like this is your left hand side like this divided by this one. That means V minus equal to R1 R2 by R1 plus R2 whole into, that is your what? V2 by R2 plus V0 by R1. Okay, so that is your, this is nothing but is your what? That is your V minus potential at this point. And V plus is like this. V plus is like this. One thing is, in case of operational amplifier, due to virtual ground concept, that is your Vd must be 0, because Vd is theoretically Vd equal to 0. Why? Because of high input high gain. The gain is infinity. Theoretically it is infinity. As far as numerical point of view, V0 by this must be infinity, which implies Vd equal to 0 due to virtual ground concept. Due to virtual ground concept, this difference voltage must be 0. That means this potential must be equal to this potential. The thing is, this V minus must be equal to V plus. V plus already you know, and V minus is already you know. From this, V plus equal to V minus. So that's why V minus equal to V plus. So we will equal V minus equal to V plus. Then from this relation you will find out what is the output voltage of the differential amplifier. So here So V plus equal to V minus, V plus equal to V1 by V1 into R1 by R1 plus R2 equal to, this is your V plus, which equal to V minus. V plus, this potential must be equal to this potential, because of, due to virtual ground concept, difference voltage must be 0. Why? Because the gain is infinity. For gain is infinity, V0 by this input must be infinity, which implies Vd must be equal to 0, which implies this potential equal to this potential. This potential is V minus. How to get this V minus? Because if we apply Kirchhoff's current law at this node, this is let, this is I1 and this is your I2, I1 equal to I2. And I1 equal to what? This voltage is nothing but V2, V2 minus V minus by R2, and I2 is nothing but V minus minus V0 by R1. From this expression, I can find out that is your V minus value is what? This one. This is your V minus, that is your R1, R2 by R1 plus R2 whole into, that is your V2 by R2 plus V0 by R1. Okay. So here R1 by R1 plus R2, R1 by R1 plus R2, this is your R1 by R1 plus R2, this will be cancel out. So that's why, so V1 equal to V1 equal to here, that is your old what? This is your R2 is there. If R2 multiplied this, R2 by R2, that is 1. That is your V2 plus here R2 into this, R2 by R1 into V0. Okay. So finally I have got V1 equal to V2 plus R2 by R1 into V0. From this expression I can find out that is your V0. V0 equal how much? That is your V1 minus V2. V1 minus V2 equal to, that is your R2 by R1 into V0. Or V0 value is how much? V0 equal to, then it will be reverse. V0 equal to, from this expression V0 equal to what? R1 by R2, R1 by R2 whole into V1 minus V2. This is your final expression like this. This will be equal to this one. So what does it mean? It is a differential amplifier. Commonly what we have discussed in the previous class in operational amplifier, op-amp as an summer, op-amp as an inverter, like this. We are applying input voltage to the inverting terminal or non-inverting terminal. But in different thing is what happen in your differential amplifier. In a differential amplifier, we are applying input voltages to inverting terminal and non-inverting terminal. The difference is, in case of differential amplifier, we are applying input voltages, maybe V1 or maybe V2, to the two terminals, that is your inverting and non-inverting. Previous class we have discussed that is your inverting and non-inverting amplifier. We are applying the input voltages either inverting terminal, either minus terminal, or input voltage to the non-inverting terminal. But in case of differential amplifier, simultaneously we are applying input voltages to the inverting as well as non-inverting terminal. So why V0 equal to R1 by R2 into V1 minus V2, this is your output voltage. And we will say that one of the important feature of this differential amplifier, it is a voltage subtractor. Voltage subtractor means what? Output voltage is the difference of the input voltages. Difference of the input voltage means what? This is V1 and this is V2. Remember that V0 equal to this voltage minus this voltage, if it is positive sign. The positive, if this is positive sign, V0 equal to this voltage minus this voltage. Or I can say, if I write V0 equal to, that is your R1 by R2, if I write that is your minus R1 by R2, this is nothing but V2 minus V1. So V2 is your upper voltage and V1 is the lower voltage. V2 is the upper voltage means inverting, non-inverting terminal. If I am applying that is your inverting terminal at your V2, non-inverting terminal is your non-inverting terminal, positive terminal is your V1, that there will be a sign will come, that is your minus sign. If you want to eliminate the minus sign, it may be what? Positive sign. That means what? The inverting non-inverting terminal, that is your V1, and inverting terminal, that is your V2. So V0 equal to plus of, if there is no negative sign, indicate that. So V0 equal to V1 means what? Non-inverting terminal V1 minus V2 and R1 by R2. One thing is, this is R1, there is a common resistance here. This resistance R2, here there is your what? This is R1, R2, this R2, that is your connected both inverting and non-inverting terminals, and R1 is your feedback resistor here also, this is also R1. If this arrangement, that means sum of the value is cancelled out, R1 by R1 plus R2 is cancelled out like this. Suppose there are different resistors are there, suppose this is your R1, R2, R3, R4 like this, then you will get sum of this value R1, R2, R3, 4 in terms of this whole into this voltage minus this voltage. If it is positive sign, so output V0 equal to some resistance values into this voltage minus this voltage. If it is positive sign, if the output voltage is positive sign, means what? This voltage is higher and this voltage is lower, obviously V1 minus V2, and there is no negative sign indicated. Okay, so that's why we will say that differential amplifier is nothing but a voltage subtractor. So another thing, another one is your what? Op-amp differentiator. What is why op-amp differentiator means what? Op-amp inverting inverter means what? Output voltage is the inverting of the input voltages. Op-amp differential amplifier means what? Output voltage is the difference of the input voltage. Difference of the input voltage means if the input voltage is V1 and V2, output voltage is the difference of the input voltage means what? Some gain into V1 minus V2 or V2 minus V1. Op-amp summer means or adder means output voltage is the negative of the sum of the input voltages. If I am applying the input voltage to the inverting terminal. If I am applying the input voltage to the inverting terminal, there will be negative signs appears at the output. So op-amp is a differentiator, that is your what? This is an minus and this is your plus. Differentiator, there is a capacitor here and there is a resistor here. As far as op-amp differentiator is concerned, this is your capacitor and this is your let Vi, and the non-inverting terminal is here grounded here, and this is your RF. Okay, so this is your V0. I will say op-amp why, how op-amp is a differentiator. Same principle, applying that is your what? That is your Kirchhoff's current law here. Let this is your I1 and let this is your I2. Okay. And this point, let this potential is your Vxa. Okay, due to virtual ground concept, let this voltage 0 means this potential must be 0. This is the principle of operational amplifier, one of the properties of the operational amplifier. Because of high gain, gain is high in case of operational amplifier. The gain is high means theoretically it is infinite. Theoretically it is infinite means V0 by this voltage is your Vd, this Vd equal to 0 due to virtual ground concept. If this is 0 means this is 0. If this is 1 volt means this is 1 volt. Whatever this voltage, same appears at this voltage because this is your due to the virtual ground concept, the difference voltage must be 0. This is one of the beauty of the operational amplifier. Now, as far as the amplifying is concerned, means output voltage amplified of the input voltage. If you use the operational amplifier, there are some basic principle. One of the beauty of the operational amplifier is what? The input impedance is infinite, and due to virtual ground concept, the Vd must be equal to 0. If Vd must be 0, the gain will be very, very high. If you want to amplify the input, properly amplified input, that is what? Using operational amplifier, this condition must be satisfied. So that as far as the differentiator is concerned, that is your, this is a capacitor and this is a resistor. Previous application of the operational amplifier, op-amp summer, that means summer means what? There are three more than one input I am applying to the inverting terminal. Here there is a capacitor and here there is a resistor. And suppose let this current is your I1 and this current is your I2. As usual process, same process, apply Kirchhoff's current law, KCL at this point, at this node, that is let Vxa. Incoming current equal to outgoing current. So I1 equal to I2. I1 equal to let I2. So I1 value is how much? Already I told you, current equal to voltage by impedance or voltage by resistance. So Vi minus Vx, the voltage is nothing but I1 equal to what? Vi minus Vx. One thing is, if there is a resistor, you can find directly find out the current, because current equal to voltage by resistance. If there is a capacitor, one of the principle of the capacitor is what? I equal to C dV by dt. Current flow through the capacitor I equal to what? I equal to C dV by dt. C dV by dt. Capacitor and inductor properties are opposite to each other. Is the current equal to C dV by dt? Current. So here in I1, I can write capacitor value is your C d by dt of V. Difference voltage what? Vi minus Vx equal to I2. The value of I2 is how much? Vx minus V0 by Rf. Vx minus V0 by Rf. Okay. So this is the one. If you make this equation, so other part will be easy. As far as operational amplifier is concerned, application of the node analysis is very much important. And if you apply the properly node analysis, if you if you consider the node particular node, then apply the Kirchhoff's current law, then if you make the equation, then rest part will be very easy. So if you will apply Kirchhoff's current law at this point, because due to virtual ground concept, I am repeatedly telling, the gain is infinity, the difference voltage must be 0, the difference voltage must be 0, whatever this voltage, whatever this potential, exactly same potential. If this is 0 means this potential is 0. So that's why if this is 0, so if you apply Kirchhoff's current law, this is a capacitor and this is a resistor. In a capacitor, one of the property is what? Current flow through the capacitor equal to I, C dV by dt. Current, in place of current, C divided into V, V is nothing but Vi minus Vx. So what happened? If this is 0, Vx must be 0. Directly, Vx must be 0. Because due to virtual ground concept, this voltage potential 0 means this potential 0. So that is your what? C dVi by dt equal to minus V0 by Rf. From this expression, you will find out that is your V0. From this equation what? So V0 equal how much? V0 equal to, that is your minus Rf into C whole into d Vi by dt. D dV by dt. What does it mean? So that is your what? So output voltage is the negative of the differential of the input voltage. Input voltage Vi, this is your Vi. Rf is a constant value. Rf is a feedback resistor. C is a constant. So what you will get? How the op-amp was a differentiator. Differentiator means what? Output voltage is the differentiating of the input voltage. That's why we will say op-amp was a differentiator. So Vi is the input voltage. Rf into C, these are the constants. So these are the constants, and d by dt of Vi. D by dt is nothing but what? Differentiating what? Vi. Vi is your input voltage. Since the output voltage is the differentiating of the input voltage, we will say that op-amp was a differentiator. Since output voltage is the differentiating of the input voltage, that's why the op-amp was a differentiator. Okay, exactly same. That is your what? Op-amp was an integrator. This is all about your op-amp was a differentiator. If you will say op-amp was an integrator, op-amp was an integrator means what? So this is your minus and this is your plus. So simply resistor and capacitor, whatever the in differentiating arrangement, you will simply alternate each other. Alternate each other means what? So there is your there is in case of integrator, simply we will interchange the resistor and capacitor. Whatever the arrangement in the differentiator. In a differentiator there is a input, there is a capacitor, but in integrator there is a feedback path, there is a capacitor. Otherwise all are the same. Principle is same, like this. So this is your input voltage Vi and this is your output voltage V0, and so that is your what? Let this is your Vx. Okay. So let this is your I1 and let this is your I2. So apply Kirchhoff's current law, same procedure. So apply Kirchhoff's current law at Vx. Apply Kirchhoff's current law at Vx. So that is your what? I1 equal to I2. I1 equal to I2. What is I1? Same, if there is a resistor, current voltage by resistor is nothing but current. Value of I1 is how much? Vi by Vx, Vi minus Vx by Rf. Not Rf, this is R. Let this is your R. Okay. So Vi minus Vx by R Vi minus Vx by R equal to I2. Current through the capacitor is your C dV by dt. C d by dt of a V. V is nothing but potential difference. V, this voltage path, that is your Vx minus V0. In place of V, that is your Vx minus V0. Then another thing is what? Due to virtual ground concept, this difference voltage must be 0. That is your Vd equal to 0. If Vd equal to 0 means this voltage 0 means this potential must be 0. Vh equal to 0. Whatever this potential, exactly same potential, because of due to virtual ground concept, this potential must be equal to this potential. So Vx will be 0. If Vx will be 0, that will be how much? That is your Vi by R. Vi by R equal to, this is your minus C dV0 by dt. dV0 by dt. Or dV0 by dt equal to minus 1 by RC into Vi. dV0 equal to minus 1 by RC into Vi into dt. Okay. So dV0 equal to dt multiplying here. So minus 1 by RC Vi into dt. Then integrating both sides. Integrating both sides. Integrating both sides. So dV0 integration is how much? V0. So V0 equal to, that is your minus 1 by RC is a constant, integration of Vi dt. Vi dt. Okay. What do you observe? So output voltage equal to 1 by RC is a constant, minus of 1 by RC, because minus means what? I am applying the voltage at the inverting terminal. That's why the minus sign will appear. So V0 equal to minus of whatever this minus 1 by RC into integration over Vi over dt. Output voltage is nothing but integration of Vi dt. Whatever the input voltage, that is integrating with the input voltage, and the role of op-amp is nothing but here as an integrator. So that's why we'll say op-amp as an integrator, because output voltage is the integrating of the input voltage. That's why it is called as an integrator. So whatever we have covered in operation amplifier chapters, that is the basic properties of the operation amplifier, and then op-amp as an inverter, op-amp as an summer, op-amp as an differential amplifier, op-amp as an differentiator, and op-amp as an integrator. So coming video we will discuss the different applications of operation amplifier, op-amp as an the application of the differential amplifier, that is your instrumentation amplifier. So coming class we will cover. Thank you.